Welcome, everyone. So, this is our 2026 I.S.Rivers webinar to talk about research and action plans for our great rivers. And so today we'll be talking about the Elbe and the Danube and a comparison of approaches to these large river systems. So let me give you just a few guidelines for the webinar. First of all, there is a simultaneous translation into French and English. So if you go to the bottom of your screen, you should see a globe that says interpretation or translation, and then you will select the language that you wish to listen to throughout. And so from there, you should continually understand the language you've chosen. Now, for questions and answers, please write them in the chat, and then the moderators will communicate them to our guest speakers. And please note that the webinar will be recorded so that people can access it as a replay. So, who's with us today? Well, a little over 300 people registered, but I guess not everyone was able to join us today. So 62% are from French organizations and 33% from abroad. So I think that demonstrates the international reach of our organization, and we're absolutely delighted by that. So as for your organizations, what we note is that we have a strong representation from research organizations, and then we also have the local authorities, we have associations, user associations. So this is an interesting breakdown. So who are we, in fact? Well, this webinar is organized by the ZABR, which is a Rhone Basin research organization under the auspices of the National Research Center. And we have 23 participating research teams, and we have 9 operational sites. Then we also have organizing the Graie, which is an association with 300 members in the Lyon area involving researchers. And it's also about the promotion of research results at not only the local level, but also national and international. And Graie is the organizer of the I.S.Rivers events. So to hear from all of the great rivers of the world, and we like to have an annual webinar in between our biannual international gatherings. So a big thanks to our partners. We have French and European funding who make all of this possible for us. So today, we are going to be hearing from guest speakers. First of all, we'll be hearing about restoring of the Danube and in particular the issues around sediments. And we'll be hearing from Helmut Habersack, who's in charge of the DANUBE4all, which is an EU Horizon project. So after Professor Habersack's presentation, we'll have some question and answers, and then we'll move on to our second presentation, and we'll be hearing about the Elbe. River and its challenges, and we're hearing about its very innovative integrated management system. And we'll also have questions and answers after that presentation. So that was my introduction, and now I'm going to hand over to Professor Habersack. He's a professor at the Boku University at the Institute for Hydraulic Engineering and River Research, so that's based in Vienna. He's also part of the UNESCO organizations and project coordinator for DANUBE4all. Over to you, sir. And you can share your screen now.
Thank you very much for the kind introduction. Dear colleagues, it's really a pleasure for me to be here today and to give you some insights into the Danube River basin and also the restoration efforts that are done there. Can you see my screen in the presentation mode?
Yes,
okay, very
perfect.
good. And you can hear me as well. Okay.
Yes, perfect.
Just to make sure. Okay, very good. So the title for today's presentation is Restoring the Danube, a river with multiple challenges and uses. And as was said, I will focus today a lot about river morphology, on sediment transport and related issues, but not only, and I will show you where we are at the moment in this project. To start with the impacts, I have to mention that the Danube, of course, is used quite a lot since many years. We have the Danube River, as you see here, regulated. Like you see here, the old Danube with the branches or meandering rivers in Germany, under branching in some other areas. And then we have now the blue dark area, which is now the regulation. At the end, this was done mainly at the end of the 19th century between, let's say, 1850 and 1890. At the end, in the upper Danube, which is more or less Germany and Austria, we have a minus of the width of about 39%, which is quite a lot. We have a shorter length of about 11%, which gives us a river that is quite regulated, which has for sediments, for example, a higher transport capacity and at the same time a change of the complete morphology. In the middle Danube, which is more or less in Hungary, a little bit towards Serbia, we have also a minus of 12% and 4% in length. Interesting enough, in the lower Danube, Romania, Bulgaria, 1,000 kilometers long, we have almost no changes, at least much less than upstream. So what we can see is from upstream to downstream, we have less impacts in that sense, but at the same time, we have other influences that are also occurring there, which is, for example, here dredging. There's a lot of dredging in order to keep the fairway depth, which for the Danube means we need about 2.5 meter water depth for low water condition. If it's not existing, we get then dredging done in 4 sections, especially with a huge number, thousands, I would say millions of tons over decades that are taken out. Now, this is, of course, contributing together with a higher regulation to the question of erosion of the riverbed in free-flowing section, which is enhanced by this here, which is hydropower in the Danube basin. Now you see here the basin. Here's the Black Sea. Here's Ukraine with the unfortunate war, as you may know. So Ukraine is part of the basin as well. It starts in Germany, goes over Austria, all the countries, 10 countries to the delta. And it's clear that the Danube is quite complex because it's the most international river on a global basis. It has a mean discharge, for example, in Vienna of about 2,000 cubic meters per second and about 6,000 downstream and 800,000 square kilometers of catchment, so quite a very big basin. Unfortunately, it was always a divide in the past as well between the countries of the western area of Europe and the eastern, and still this is a topic. And we had wars also in the basin in the Balkans, as you may know. So it's quite a delicate situation. Concerning the river, the red dots here mean each of the red dots is a hydropower plant. Like we have in Austria about 5,200, we have many of them in Germany. We have less in the other basin, but this is now changing in the Balkan areas. There's a lot of new hydropower plants being built. And of course, in the old days, when the historical hydropower plants were built, sediment continuity was not a topic. So there was no one talking about bypass systems, about sluicing and flushing and how to get the sediment through. That means we have from the sources of the sediments in the mountain areas of the Alpine region, for example, Carpathians and also Balkan areas here, less and less sediment that goes through. So in essence, it means less sediment from the flux for the input, from the catchment, more dredging, taking it out. It's forbidden now in the upper Danube to take sediments out. It is bailout of the system. At the same time, a smaller Danube and a steeper one. This is a combination. This on the long term will not really work out. So this is kind of something we wanted to know because it turned out over time that the Danube has an issue in this respect. And whatever you do in restoration, we cannot isolate restoration from all the boundary conditions. So we want to know, like a medical doctor in a way, what is the issue? What is the health problem we have? Because we want not only to fight against symptoms, but we want to really go to the source of the issue. And what is the consequence of this all is that we systematically change the whole condition. This is the longitudinal section of the Danube where 2000 kilometer 2000 is Vienna here. So I sit here at kilometer 2000 and here's the Black Sea. And what you see is two lines. The historical line here, in this case, only suspended sediments, smaller 1 millimeter. It's even worse for the bed load. And then you see a reduction, obviously, from about 40 to 60 million tons, including sand, to now 15 to 20 million tons per year. This means we have a minus of 60% input of fine material to the Black Sea. And as I said, the bed load is completely interrupted in the system. Now, this you can show here also not only for the Danube, but also for the tributaries. So you see here the mighty Danube as it used to be, let's say, before the hydropower plants were built, when we had data, the first measurement data available are in the, let's say, 20s to 30s of the last century, compared to the existing situation today. So again, the same thing, 40 to 60 million tons per year versus 15 to 20. But you see how mighty it was also in the tributaries, I.S.Rivers, ZABR, Morava, before. So the balance, and I have no time to go into the balance equation here too much, but it's obvious that we have here a change of the storage of sediments as well. So that means we have either too much sediment, and you see it here as well, in the various areas, like here, the hydropower plants, they have more input than output is going on, like the Iron Gate in Romania, Serbia area has about 80% of trapping efficiency. So 80% of the sediments that come into the reservoir, which is 300 kilometers long, don't leave it anymore. So it is no wonder that at the end of the day, there must be a change of the system. So this is really what Matt Condor from the USA once from Berkeley mentioned, hungry rivers. So we transferred the rivers into hungry rivers. And this is not only for the Danube, it's the same for the Elbe River, it's the same for the Rhine River, but also the African rivers, even the Mekong and the Mississippi, they have the same topic. It's a global thing. And once you have this kind of picture, and as I said, for payload, it's even worse, then we have to see that there must be some consequences because some of these input and output variables are not in equilibrium anymore. We know that the river is never really in a full equilibrium, but what we would like to see is a dynamic equilibrium. Now, what is the consequence of all these changes? When you go to the delta, you see here in various pictures as well, also in some graphs here in figures, you see this erosion of the sand beaches. You see damages occurring, you see protection systems. At the end, Romania loses every year up to 24 meters land. It's getting smaller over time, and houses that are here, small fish houses, they are taken and eaten up by the current of the sea. So here's the Sulina Canal channel that is a navigation route, which is eroding at a rate of 6 centimeters per year as well. So at the end, the coastline is going back. At the end, the channels, we have 3 channels in the delta, they are going down at 6 centimeters per year, this Sulina. And this means it can lead to delta subsidence at the end, which is not good because if you have sea level rise in the sea and the sinking of the delta, that would be not a good idea. And also on top of this, we get saltwater intrusion, all consequences. I have not time to go into all this, but it is not a condition you want to have. Now there are countermeasures like in Upper Adria or for the Rhine to dredge sand in the sea and put it back to the sand beach, which we all like in summertime. But there's a lot of millions of euros cost involved. And also we have a disturbance permanently on the ecosystem. So we need to think, can we not improve the conveyor belt? Because upstream we have too much sediment in some of the areas. Now what you see here is just some figures. Like here you see without the trend line, basically the years in the Austrian Danube, and you see the bed level, it goes down and goes down and goes down. It's 1 meter lower than it used to be 60 years ago. And it can be worse, like here in Hungary, it's 2, 3 meters, even more going down. You see it in Romania, Bulgaria, you see also the cross sections here. This is not something what we would like to see, because with this lowering of the riverbed, also the groundwater level adjacent to the river goes down in the same amount, more or less. So we see then drought conditions, less, let's say, groundwater renewal. We have also flood risk issues because the inundation characteristics is changing. And we have also loss of all habitats for fish and birds and so on, vegetation. So this is not something we would like to have. And time-wise, I split it, but when you go on like this, can lead to a nick point, to a catastrophic situation when you cut into the fine marine deposits. Like the Danube in Austria has somewhere here a line where the gravel from the ice age stops and we go into the fine material of sea deposits, sand, silt, and clay, what we call a riverbed breakthrough. And we don't know what happens there. We don't want to know it, of course. Also, don't want to see it, because then we can be almost sure that navigation might not continue. So we want to stop the riverbed erosion. And the opposite, just in the same river reach upstream, you see sedimentation of one reservoir, the biggest trap in Austria. So over the 60s, beginning to 2002, we had sedimentation. The red area is always surplus, leading then in a flood condition like in 2002 of a remobilization of about 4 million or 5 million cubic meters of sediment. And they are then deposited in the floodplain with a flood risk issue. You see a person there. So this is 2 to 3 meter deep and high sedimentation of material that came out by an unintended flushing of this reservoir. And then you have again starting the same process, filling up. 2030, next big flood. We talk about 100 years floods in this short period of time. We all know the statistical issues with this. The same story, and now it fills up again. So we don't want to see too much, hopefully. So we work quite hard in the DANUBE4all project, but also in other projects, Danube sediment, to get less of this zigzag here, to get more sediment continuity going on. So we have this kind of unintended flushing going on. And for the riverbed, you see here the whole erosion and sedimentation conditions. Red is always erosion. Then the yellow brownish colors is sedimentation. You see again the Iron Gate Reservoir here. And the green one would be a dynamic equilibrium. And out of the whole reach of 2,600 kilometers, we have only 10%, 260 kilometers, what we would like to see an equilibrium, as said, and in a dynamic way. Otherwise, we have too much erosion, 56%, or sedimentation, 34%. So why would you not cooperate in this? We have to cooperate that the hydropower plants, which don't need the sediments, get rid of it. And the ecology, environment, flood risk, drought risk, they need it to stop the erosion. So in other words, we have to do a restoration in order to get to a situation where this disequilibrium is changed. And the good news is that a few years ago in the River Basin Management Plan, the last one, it was already realized and signed off by all ministers of the Danube Basin that we have a problem. We have a completely disturbed Danube condition when it comes to sediment. So a vision was formulated to reach a balanced sediment regime and undisturbed sediment continuity. So we know that this is never possible because we need also the hydropower plants for energy production and navigation and so on. But this was more visionary formulation to know in which direction we should go without saying that we can reach it completely. And this, of course, would create the habitats for the aquatic communities, groundwater dependent terrestrial ecosystems. Now, in the new plan, which is coming up next year, as you know, the next River Basin Management Plan will now take things up in a so-called Danube River Sediment Management Plan, which I will not go into detail today. But we can do something. This is just a compilation of measures. It starts in the alpine environment, in the catchment, so to say. It goes to the reaches, It goes to local scales of the hydropower plants where you want to get the sediments through it. Either you get it through by bypass systems, local bypass, let's say flushing and sluicing, or sometimes you have to dredge it and to redump it. Like in Vienna, there is a redumping of sediments at a rate of 230,000 cubic meters. The electricity company is putting every year into the Danube to contribute to the stopping of the erosion of the riverbed. For this, you can download this if you want to search for it in a so-called Danube Sediment Project. Another project is mentioned here. We have identified over 50 measures only in the sediment context with 2-page fact sheets where you can find measures at the various areas. For example, reconnection of side arms to enhance the floodplain erosion, because we see also that if you have here no water and no connection and riverbed erosion, it's falling dry. It's not only for the ecology a problem, but next time then the inundation changes, you get sedimentation of fine material, and then you have the riverbed erosion on the one side and sedimentation of the floodplain on the other side, and then we get even worse conditions, which we don't want to see if possible. So we have a lot of measures defined. Now, to jump to the DANUBE4all project, which is aiming to do some restoration of the Danube River Basin waters for ecosystems and people from mountains to coast. Very ambitious, it's 5 years. It's kind of a Danube Basin Lighthouse project. Now, the main part of this project is, sorry, I should stop here. We want to develop what we call here a restoration action plan for the Danube River Basin. That means we work together with 48 partners, and we are in the last year already now, so I can show you where we are. Basically, to first analyze the problems we find in the different areas of the Danube. We know many of them already. Then to define solutions and measures, and then even to put the measures roughly in certain places to have some idea of what could be done. And maybe some of these measures are taken up in the next river basin management plan directly. We do this as usual in work packages and have not time to go into this. We have 2 science work packages, an abiotic one, which works on the free-flowing river concept. Of course, no surprise, we found out there's almost no free-flowing river reach larger than 4,000 square kilometers in the basin. We did a lot of modeling of habitats and fish species. Our key fish species is the sturgeon, the caviar fish, with a length of the maximum of these fish is about 4 or 5 meters long and a ton of weight. And we want, of course, to work that it's not extinct, hopefully in future. We also work a bit on economics because we need to go with infrastructure to see it also as a construction measures and give something back to the economy. So €1 invested in restoration should lead to some multiple euros coming back, which is just based as an economic analysis as well. We work a lot with the citizen science, with communities, with a lot of these kind of river walks done, very interesting, drinkable river concept, theaters, public exhibitions, but in many projects you have similar concepts, I guess. Then we have restoration sites. We really built something. I didn't put it in the presentation. If anyone's interested, you can write to me. We have an island which we restore as a demonstration site. So money of the project goes into real work, to real implementation, and also then to get monitoring data. The idea would be to use islands, maybe to replace some groins in some places to give the 2.5 meter water depth because it's narrowing down the width. At the same time, it is a habitat. At the same time, it can be a source of gravel augmentation to compensate the deficit. And then work package 7 is just the plan. As such, we work hard into this direction to get it done by the end of next year. Now, we developed these steps which are quite logical: problem analysis, aims definition, measures selection, we developed an automatic system to assign measures to problems, and then a tool to put the measures in place. I just show you this to get some insight. Now, what we do, and we're right now is we defined here about 95 restoration measures. It's always growing because we have also included our sediment quality as one of the issues for existing 55 measures. So we have more measures to cope with these problems. And this means we can really have this hope that we use this. And what we did is we put here the problems on the other side in a big Excel table and another tool later to have with these X's measures to help us to solve a certain problem. So we have measures here and we have problems there, and this gives us the chance, once we identify the problem, to automatically get suggestions in this GIS-oriented method and tool we just developed to get some measures suggested. So we have the problem first, then we have the measures then, and then we get, if we click through here, suggestions of measures. So if we see a change in payload volume, we get an automatic list of measures, what we could do. And then in the system, you can click on those and say, this is in my reach, in my area, not possible. So you can exclude measures and continue with then the tool to implement these measures. So it looks somehow like this. You have two screens, sub-screens here, where you have on the left side the reaches, so that the name was done in a kind of homogeneous reaches intersected, which are not the same as the water bodies. So we did a kind of a new approach together with the ICPDR, the Danube Commission, to end up with 3,000 reaches. For each of them, you can click on them, and then you get the chance to identify the problems. And you have many base maps here, which help you to do the analysis, showing, for example, the structures, the measures, the regulation, the groins, whatever you have there, dams, in order to get this done. This can be done without starting the ArcGIS. You can simply use the tool, and then it's quite convenient at the end to say, yes, I did this analysis, and I get this suggestion of measures. And then afterwards, you can take the same system to select measures you would want to put somewhere, and then you can drag with your mouse measures to a certain place, like a hydropower plant. You want to improve the sediment continuity for payload. You put this symbol, and we are not fully there. And with this symbol, you are able then to select detailed measures which you want to suggest for this area. So we don't do a planning there as such, but it comes up with hundreds and even thousands of measures at the end of the day for the basin. And then we want to know what the cost in principle is for this and what it is good for the economy as well, with the hope to find measures that are going for win-win conditions, supporting, of course, the environment, but also, let's say, allowing the economical use as well to go on in a certain way. We focus a bit on nature-based solutions and ecosystem services, but I have not, unfortunately, time to go into these details. There should be a paper soon coming out, because it's also a topic. Many of the measures might be in a yes or no condition, no nature-based solution, but we said it is not always yes or no only. We can, according to the UN definition of nature-based solutions, have in a 1 to 5 scale different, let's say, values with a full-fledged nature-based solution or some intermediate one still being a nature-based solution, but not a full-fledged one. So we can then assign they select a measure here, and you put the measure to a certain place. And at the end, you can then say which measure you want to choose. And then you have something in the head, this planning tool, which maybe the Danube Commission might want to use as well for the basin management plan in order to have a systematic approach. And then, of course, this can be used to track the measures that were implemented and to see also the change. I should say, which I have also not time to go, we developed also a hydromorphological assessment method, a new one with a hierarchical approach to say what is the problem in certain areas, but looking always to the catchment as well. And sometimes the catchment gives you an information that a certain reach is in a worse condition than you would only see if you look only in the river reach, because then you miss the sediment discontinuity, and this gives you a nice picture, what you see in nature, but in reality, it's affected by the catchment processes. At the end of the day, it's not the final look what you will get, but we will see then for the basin hundreds, maybe thousands of measures. We work at this quite hard now. We do it in two projects, in the Danube sediment for the sediment measures and in the DANUBE4all for all the other measures. We do not go into flood risk, so we are not doing flood risk measures to keep settlements, but flood related relevant measures are included as long as they are combined with the restoration effects. So at the end of the day, we might have here a plan at hand for the Danube the first time, which gives us a scenario for the future until the year 2050, whereas eventually it can be improved with the experiences. It can be further used for monitoring the success. It can be used also to give a planning tool in order to get the restoration done. But I can say without the proper sediment management, without the proper sediment continuity, without the proper width, slope, sediment flux, it will not be possible to get the Danube a successful river basin improvement when it comes to restoration. And by the way, restoration is not meaning to go back into the 19th century, because in Austria there was a big discussion about the restoration law. You remember? There was this discussion, and some people were saying we lose all the agriculture. Some other people were saying we lose all the environmental boundary conditions. So maybe neither is true. We have really to find a solution where there's a coexistence between a certain weight slope and sediment flux, as well providing a positive impact for agriculture, for hydropower navigation as well. So at the end of the day, we should have more fish biomass again, but also to allow a certain economic use, but not having this silo thinking only, but have an integrated approach to put river restoration in a future generations perspective. And to finish off, we have, of course, key topics to be included, which is, of course, the upscaling. We need to go into socioeconomics business benefits. We have demonstration sites to demonstrate it. We want to use and look into the biodiversity strategy as well, habitats directive, restoration targets, the mission, as you know, the EU vision approach is part of it, where, of course, I couldn't go into this as well. We work a lot into participation processes to talk to the people, get their opinion, and the plan should be written in layers so that every layperson can understand it, but then you can click on the measure and get the fact sheets and get down to papers explaining more details. And of course, we need to work with all the partners in the authorities, in the citizens and communities. And at the end, our hope is for the next generation to get some idea how we could improve the Danube River to a better condition than it is today. With this, I thank you very much for the attention, and I finish my presentation. Thank you very much.
Thank you very much, Professor Habersack, for this very interesting and ambitious presentation. N'hésitez pas à poser vos questions dans le chat. Alors moi, j'aurais peut-être une première question
I
à
perhaps have
propos
a first
de ce
question
projet DANUBE4all, qui est vraiment quelque chose
on
de
the
très
Danube.
ambitieux à une échelle très ambitieuse. Je me posais la question de comment vous envisagez le transfert de ces outils à ces échelles-là. Est-ce que j'imagine, peut-être, j'ai peut-être pas vu, mais peut-être un work package qui prévoit ça, ou est-ce que vous y avez déjà pensé, parce que ça va être très, très compliqué, beaucoup de pays, beaucoup d'associations, beaucoup d'organisations.
The translation started but stopped at some stage.
Sorry,
Sorry.
the question was
Okay,
how are you planning
no
for the
problem. I'll
transfer
finish again.
of this,
I
as
was
there are
just
lots of
wondering
organizations?
if you've already
Okay.
thought about how to
Now I
transfer.
get it.
Yeah. Okay.
No, I get it. Thank you. I mean, the first closest partner here is the ICPDR, the International Commission for the Protection of the Danube River. The same you have at the Rhine with the ICPI, the Elbe with the ICPE. So it's this organization, the river organization, that's our closest partner. Second is also the Danube Commission for Navigation. So we sit together quite a lot. And the idea now is to take this, what we work out in this project, DANUBE4all can be a source of inspiration, information, and also they can maybe maybe some of the countries want to use it as a planning tool to take not all the measures. I have to say no one will take all these measures. It's too much expensive, but they can select what they think can be implemented in the next phase of the next 6 years. But we want to put a planning horizon so that we then can say we have some ideas even going further. And if there's some money available or even some other chances to have enough information available. So that's one way to go. The second one is, of course, also in the restoration plan for the restoration law. We are almost too late for this one because, you know, these restoration plans have to be done this year. So we also work with some ministries there. Maybe some of the ideas can go in there. The third one is the National River Basin Management Plan. So the national ones, but I have to say it's a limitation. We are focusing on rivers larger than 4,000 square kilometers because it's too much otherwise. So we don't go into the small rivers, less than 4,000, but still it's a source for the larger ones of inspiration. And then we work with hydropower companies a lot. We work with navigation companies and so on. So basically all stakeholders with the national parks. We have projects at the Danube, which is called Danube Island, Wild Island. So we work quite closely to the national parks, environmental groups. WWF is very much included in our project as well. So it's kind of all the stakeholders basically. And then, which is demanding is to get to the people. You know, in the mission, we need to work with people and we want that, but we have 80 million people in the basin. So how can you talk to 80 million people if you take out the kids? For example, okay, it still goes for 60 million, I don't know. It's not possible. So what we want to do is to use media. So we reached already millions of people, unfortunately, but it's still not enough. So what we want to do is to join the forces with the ICPDR because they have to do a public participation process. So once we have our tool available, they can use the same tool to show it. And at the end, everyone, like when we go to TV shows or whatever, we don't have the tool yet, but then everyone can open it for free, have the mouse and get inspiration. And then, of course, in the demo sites, we have local people directed to do what we call co-design and co-creation. Very active people in these villages. They have new ideas. Some ideas will work, some ideas will not work. It's quite hard, of course, time consuming, but it's really worthwhile because and school kids as well. So I can't tell you every detail now, but I think it's very much demanding for us and we have to go out of our science box as well to open us for critics. They can come to our lab to see the models. Anyway, so this is a long process. We do some step forward, but it's the only way in future to get enough people. They are also voters. You know, when they are convinced, the politicians will react. That's my hope. So once we got about 10,000 people coming to see things. If every university does this on the long run, I think, and I know you do it anyway, or other organizations, so if we join forces, I think we need to take the people on board. Without the people, it is not working. And they get sometimes no information, and sometimes they think we are doing only silo, both
Ok, merci.
science. Anyways, I stop here, but this is well known to you.
Merci beaucoup.
Thank
J'aurais une
you
question.
very
Quand
much.
le
I
Danube
have a
traverse de
question.
nombreux
When the
pays, a formuler
Danube
des
flows through
réglementations
so many
différentes, donc
countries
quand
that
vous
have
mettez en
different
place vos
regulations,
suggestions
so when
d'opérations de
you make your
restauration,
suggestions
est-ce
for
que
restoration
tous ces pays ont
operations,
les
do all
mêmes types de
the
réglementations? Je
countries
pense
have the
par
same
exemple
sorts of
à une
regulations?
autorisation de
For
draguer
example, an
les sédiments
authorization
en
for
cours d'eau ou
dredging
pas,
sediments.
suivant les pays.
Is it the same
Suivant les pays.
regulations in the
Ça demande
different
quand même aussi une
countries?
harmonisation ou de la
So,
négociation sur ce qu'il
or
est
is
possible
there
de faire ou pas.
harmonization
Je ne connais
possible or
pas la
negotiation
réglementation
that's
de tous les
necessary? I
pays,
don't know what the
mais
regulations are
voilà.
in all the different countries, but what can you say about that?
Yeah, that's a very good point. I think very important and most important is that we have now the EU regulation, European Union regulations, which is on top higher than the national legislation. So when the EU Water Framework Directive, of course, has some target, this is supranational, so it is on top of this. So we have to reach the good ecological status. Now we have to show that in order that we reach the good ecological status, we need the sediments in order. This is a difficult job to prove, and we did that we need the sediments in order to get the habitats. Once we have the habitats, we could get the fish back. This is a tricky thing. So the water framework helps us a lot. The Floods Directive helps us a lot. We have the Renewable Energy Directive, and they are competing sometimes, which is an issue, I have to say. So also with the DGs in Brussels, we have to closely work together. The DG Move and DG Environment, they have the same voice, When they have different ideas, then it's not good because then you go to countries and it's not clear what is the target. But I think this is the first point. But it does not help us. We have to talk to the people, and the ICPDR does this job. So they have every country has experts, and you know the process. They come together, what we call in the River Basin Management Expert Group, and they have the HYMO expert group, the Hydromorphological Expert Group. So whatever we do in our projects, we go to their meetings and discuss this. That means the methodology for the HIMO assessment went through a lengthy discussion process where the governments were sitting on the table, and at the end, we had to discuss with them as long as necessary to get a green light. So it is demanding, but it means once the experts from the countries agree to something of methodology, then it's done. So then it's last year in summer, we applied then a new methodology on what we call a joint Danube survey, which all countries contribute. So it means, of course, there's discussions, of course, there's need for agreements. So we do it within the ICPDI in these subgroups where the countries have the experts sent there. And they have to agree to the method. So we have a scientific methodology, we can write a paper, but if it is accepted, is decided not by us, of course, but by the country's representatives.
Une nouvelle question.
One more
Est-ce que
question.
vous avez vraisemblablement un
Very
plan de gestion
probably you
des
have
sédiments grossiers à l'échelle du
a
Danube?
course
Vous en avez peut-être
sediment
parlé,
management
ça
plan
existe
for
bien,
the
ce type
Danube.
de
Does that exist, some
management
sort
plan?
of management plan?
You ask a very, very good question. Tomorrow, Wednesday and Thursday, we meet in Bratislava in Slovak Republic in order to discuss this plan. It's another project, Danube Sediment Q2 it's called, another Interreg project. And there the idea is until the end of this year to write the first one. It is not existing yet, but the first sediment management plan for the Danube Basin. So it's very demanding, I can tell you. So we use the same planning tool I just showed you before. For example, to give an example, we go to a river region and ask ourselves, do we have a riverbed erosion? Yes or no? If you have a full hydromorphological assessment, we get 30 parameters. Not in all regions we have it. The minimum is we need to know this problem exists or not. If the problem is not existing, you don't need a measure. But if we have a problem, then this automatic system suggests you measures to stop the erosion. And then you have to go manually in a way to each of the regions to assign measures with your mouse to some places. And we don't ask ourselves, do we have the money? We don't ask ourselves if we have the land available. That comes later. But we do respect, of course, needs for flood risk. We do respect navigation. We do respect hydropower in a way. So we don't say we take out a hydropower plant in a big scale or something. Maybe for smaller it is discussed or not. Anyway, so with this, we hope that by the end of the year we have the first sediment management plan according to the EcoStat document. You know the EcoStat document on sediments, and there is some sediment management plan included. This is what we follow exactly the steps there, the 6 or 7 steps we go through, and then we will see. It will be, I think, as a pilot, so I don't know yet the final version, but we have some vision, and I can tell you in half a year how it looks like. It should be accessible for all of you afterwards, but it's not yet ready, unfortunately.
Merci. Peut-être deux dernières questions, parce que je vois que le temps passe. Est-ce que l'outil cartographique en
One
ligne
or
que
two
vous
less
avez
questions.
présenté,
With
est-ce
the
qu'il est
mapping
déjà
system you showed,
accessible,
is
ou
that
est-ce que c'est prévu
already
pour la fin du
accessible
projet?
online, or is that at the end of the project that will be made available?
Yeah, it's actually just coming warm from the oven for us. So we are in the we are doing these tests now, and I think by the end of this year it should be in a mature condition. Right now it's more in a test phase, but we have still we now put a survey in place because of course sometimes it's needed that the countries have a first look on what we suggest. So we want to do it with them. So we cannot have the open access directly, but I think the tool itself should be available afterwards for another river, just to play around or to use it or optimize it. Should be open source as well, so you can further develop it. But right now, it's not in a stage we can do it. But I think by the end of the year, it should be possible. You just can write to me and we find the situation.
Très bien. Et dernière question, vous avez parlé d'une stratégie
And you
de
talked
restauration.
about a restoration strategy.
Quels sont vos systèmes de suivi
What
pour évaluer le
monitoring
succès
systems do you have for
mesures de
assessing the
restauration?
success of
J'imagine que vous avez beaucoup de
restoration
suivis qui sont faits en
measures?
partenariat
I
avec des
imagine you do a
scientifiques.
lot of monitoring with
Est-ce qu'il y a
scientists.
une stratégie particulière?
And do you have a particular strategy for this, for the monitoring?
Yeah, we work in the Danube sediment project as well on the sediment monitoring, for example. That means we have in the past complete different systems of monitoring the suspended sediments. Like some have turbidity meters and so on. And we found out in the last project already that we did joint measurements between two countries in the border section, that there was a 3 times difference, let's say, in the quantity. So we developed now a standard for the Danube River, how to monitor suspended sediment in the same way. And this was gradually put to all the different sections of the river. So now I can say that the suspended sediment is harmonized. For the bed load, there's still more missing, but we've also some strategy, monitoring strategy in place, how we want to go for it. For the sediment quality, it's now a joint work, almost finished, I would say. Also available soon, how you monitor the quantity and the quality, heavy metals, and PFAS and all these. Very difficult to combine, and unfortunately, I have to say that sediment quality and quantity always have not the same, sometimes not the same aim, because sediment quantity people like me want to get the sediment through. Sediment quality people would say if there's a contamination, maybe it's better the sediment stays in the reservoir and doesn't go to the delta. So we have to find a way forward, which we discuss in the plan as well. For example, to dredge the contaminated sediments, dump it or whatever. The fresh sediment is better nowadays because we have more wastewater treatment plants, we have more regulations. So for the sediments, it's improving. It's not yet there, I would say, by far not. Then we have Earth observation recently in our projects included quite nicely. You can use this as one additional. Of course, we have all the ecological parameters according to the water framework. This is a standard in a way, all the water framework parameters we have in place. In terms of the water quantity, there's a lot of data, unfortunately available. When it comes to the riverbed, it's very different again. Every country has a different condition. Like in Austria, we have a very dense set 2 times a year. Cross sections 50 meters apart are taken for a 300-meter wide river. So it's really, you have a very nice way to see the complete picture of the morphology. In some other countries, we have 1,000 kilometers and maybe not yet the full-fledged morphology data available. So we were advocating to do more repeated cross sections or multi-beam measurements to get the bathymetry, because it's also interesting, of course, as we know, and they have the groundwater monitoring and so on. But this, I should say, we are slowly but surely approaching more harmonized way to do the monitoring. And then at last point, we do a joint Danube survey, JDS is called. It's every 6 years, and we did it last summer. And this is really very good to harmonize the methodology. So we go with ships in the past, now from one country to the other together, and we do the same thing from upstream to downstream, the same method for fishing as well as for benthic organisms and so on. So you get then a momentary status picture. It's not so in depth in all areas, but this gives you, this joint Danube survey was really good, that people come together, experts, also from the administration, and do it from Germany to the Black Sea to Romania in the same way. It takes 6 weeks or more, eDNAs taken and things like that. So at the end, it's another way to get forward. We are not there, I would say, fully, but it's a progress.
Très bien, merci, c'est déjà beaucoup. Vous ne devez pas vous ennuyer.
Thank you.
Très bien.
I'm sure that keeps you very busy. Thank you very much for your presentation. But we will have to stop there, unfortunately, to continue discussing. And now, thank you once again. And we're now going to move on to the next presentation. Mr. Puhlmann, Director of the Administration of the Biosphere Reserve of the Middle Elbe, who's going to talk about his experience on the Elbe.
Yeah, thank you for your introduction. I want to speak about the Elbe River. I'm working, Germany is a federal republic with 16 federal states, and I'm working in a federal state administration in Saxony-Anhalt. It's one of the 16 federal states in Germany. I want to speak about the Elbe River, especially in Germany. That's why in Czech Republic, it's another part of the Elbe river basin. Restoration is not so important thing like in Germany. The structure of my presentation is a short introduction about river challenges and so on. Some facts about solutions and one example in a biosphere reserve. And then I will give some experiences about a best practice example, possibilities of overall strategy named GKA. At last, I want to speak short about evaluation and the short conclusion and the short outlook. Thank you. Here you can see the river basins in Europe. You can see the Elbe River Basin is a very small river basin. It's in an international river basin, like it's not so international like the Danube we heard from Mr. Habersack. The Elbe River Basin is around 150 square kilometers in size. In Czech Republic, a little bit in Poland, a little bit in Austria, and then in Germany. We have an international commission for the protection of the Elbe River. It's a good collaboration between all states, and some kinds of times we have a good monitoring along the Elbe River in all states. It's a good collaboration. In Germany, we have two Elbe River Basin community to finish the aims of the Water Framework Directive named Elbe River Basin Community, FGG, and this community is working good together with International Commission. We also have a length of 1,094 kilometers, and in Germany, be 727 kilometers. It's very short. The Danube is a more long river. I'm working in a biosphere reserve. It's in UNESCO thing, and the biosphere reserve is a long-term project. Our biosphere reserve was founded in 1979 in East Germany in the GDR. The state is Perdu, but the biosphere reserve is present and is working. It's a good thing. It's a long-term thing. We have survived significant political changes, and it has been expanded for 2 provinces or federal states after 1990. I'm responsible for this part from 300 Elbe kilometers in green color. I hope you can see it. We have some World Heritage sites along the Elbe River, Bauhaus, Dessau, Luther, and so on. And we work together, all UNESCO sites work together for the river. I want to speak about typical river problems in Europe. The Elbe as an example, and the biosphere reserve as an Elbe example. I can speak better about the biosphere reserve and not so good about the Elbe as whole river. Biosphere reserve, I said that, are UNESCO model regions for sustainable development. All important processes in floodplains depend on water. You know it. It needs regular flooding to sustain the ecosystem. It will be very good if you have every year a small or a big flood. Mostly, and sometimes it's lower water levels and lower dynamics, and we have an increasing influence of climate change. It's a problem, it's a big challenge, and not all what we must know, we know now. We have to do to make the right things now. A good management, I think it needs a look into the history. Space and time are important in this thing, and the space here on the Elbe River, along the Elbe River, is you must have a look to the Elbe River Basin catchment, and you must have a look in time in the last 1,000 years. It's the time where people have made some things along the Elbe River. We had some milestones. Here you can see a slide with former riverbeds of the Elbe near Dessau. The river formed the floodplain since the ice ages, and since 19th century, the floods can't form the floodplains, not overall. Today only it's possible, allowed to do so in a small weight. We have a loss of up to 80% of floodplain. We have an extension of waterway, and we have in some districts soil erosion of the Elbe, also riverbed erosion. Mr. Habersack spoke about riverbed erosion along the Danube, along the Elbe River. In some parts we have the same. We have some limitations from the history. We have a lack of material and water because of some dams in the Elbe River and barrages and its tributaries. A good thing is the Elbe in Germany is a free-flowing section from the border to the Czech Republic up to Hamburg. We haven't dams in the Elbe River, and that's why it's very good for nature protection, for nature and for the ecosystem. In the Czech Republic, the Elbe has some dams and no flowing sections. That's why the people in the Czech Republic are not so interested in restoration things like in Germany. Our potential is more than bigger as in Czech Republic, and sometimes it's not so difficult to realize such projects like where. We have a loss from up to 80% as a loss of floodplain areas by dikes. And we have a land use which makes the water faster in the whole catchment area. It's a problem if you have big floods sometime, but it's also a problem if you have small rates of water. In history, some measures made the river shorter. Along the Elbe, we have a loss of about 80 kilometers in length. It's a very big weight. We have, I said in the slide before, coarse fixation, and since the 19th century, and the Elbe was developed as waterway in Germany until to the 1940s. In the Czech Republic, it was developed up to today. In the GDR time, the people built a not new waterway structure. It's a good thing for the ecosystem today, and it's a good thing to make restoration. Since then, riverbed erosion has increased in the river, and floodplains are increasingly disconnected. The lateral connectivity is diminishing. Oxbow lakes have not been able to regenerate since then. Some Oxbow lakes, not all. As Oxbow Lake outside of the recent floodplain. What needs to be done for nature conservation in the Biosphere Reserve or along the Elbe River? So we try to improve typical dynamic structures and dynamic processes in rivers, Oxbow lakes, channels, and floodplains. We try to take the old floodplain areas back into the recent floodplains. The best measure are dike relocation measures. We made some such measures last years. And for me, very important, we must work together with water maintenance organizations and administrations, shipping route management and flood management. And don't forget climate change, think in worst case scenarios. It's our experience. I must explain, in Germany, it's sometimes a little bit complicated. The Federal Republic is responsible for the waterway. The federal states are responsible for nature protection and for realization of water framework directivity. that's why we must collaborate good, and sometimes it's difficult. You must have trust. Oxbow lakes cannot, we don't have new Oxbow lakes in future. That's why is the restoration of Oxbow lakes and dead channels, old arms, very important. And we have since 1979 a small program to make such restorations. You can see a map of Saxony-Anhalt, of my Biosphere Reserve, and you can see some projects are completed and some projects are working in progress. The projects are mostly very big. Some 100,000 cubic meters of material must put outside of the Oxbow lakes, and it's sometime a problem of waste laws and so on. I think you know some about this facts, and we also in history had some chemistry along the Elbe River, and we have some materials and some elements in the soils of the floodplain. Big part or important part of our strategy is our river and floodplain restorations projects. We have a good history. Last 20, 40 years, we made such or organized such projects. We initiate such projects. We coordinate large and long-term projects of nature conservation. Our partners are various. Be partners or advise and be partners of governmental organizations and administrations, and also from non-governmental organizations and administrations. Not some on the right side. You can see some examples. In German, named in Naturschutz Großprojekt, also big nature conservation projects, sometimes 10,000 hectares and sometimes much money. One project is ready. We work together with WWF. Some projects are going up to next 10 years. In collaboration with NABU, it's also an NGO in Germany, and our newest project is named here C. It's a project with a foundation, Zielmann Foundation. It has about 70 million euros budget and 4,000 hectares. It's a project against riverbed erosion. It's very important, and we are very happy that we have get this money and we can work the next 10 years. And some other projects are here, but I haven't the time to speak about this. One example, here's the largest dike relocation project in Germany. It was realized not from the water administrations, but we realized it as Biosphere Reserve together with WWF and in collaboration with the water and flood administrations. We are very happy. You can see in blue color the former dike, and you can see in red color the new dike. And between the former and the new dike, we have 600 hectare new old floodplain area. It's important for floodplain protection, but also important for the ecosystem in the Biosphere Reserve. We are happy that it's ready. We had some discussions and problems with land users and inhabitants, but all problems we solved in 20 years, and now it's ready, and we hope that we will have sometimes a flood in this area. The most important thing is how we work together with the waterway as a federal waterway administrations. We have about 400 kilometers waterways in the Biosphere Reserve. In Germany, 700 kilometers waterway and about 1,000 kilometers of dikes. Constructive cooperation with the federal waterways and shipping administrations and the state water management authorities is a central task. and an important success factor. I said this in the slides before, but here also. Among other things, several hundred structures have been ecologically improved and many dikes have been relocated. Ever the question all depends on water, and that's why all the administrators which have to do with water must work together. Mostly we have constructions, waterway constructions as groins. On the right side, you can see the technical type of groin, and on the left side, the ecological measures which are possible as a toolbox. We have realized some hundreds such measures, and the groins are good in function for the waterway and better than before in function for the ecosystem. It's good for some species. Later I will bring some examples. After GDR time in 1990, the question was what to do with the Elbe River as waterway. New barrages, new water power stations, or more ecosystem measures. It was a long-term discussion with NGOs, with water maintenance administration and politics and society. And we needed, all people thought we needed an overall strategy for the Elbe. And since 2017, we have an overall strategy for the Elbe named GKA. In the next slides, I will speak from GKA. The partners in this strategy are two ministries of the Federal Republic and 6 federal states along the Elbe River. The district for this overall strategy, GKA, is from the Czech border up to Hamburg. It's a free-floating section of the Elbe River in Germany. Very important is the equal treatment of waterways, water management, and nature conservation according to coordinated guidelines. The rapid implementation of the GKA represents a unique opportunity for the river and for a task for generations without adequate alternatives. Also it's a work for generations, not only for the next time. It's the same like along the Danube, which we heard in the last presentation. We have no more a lack of knowledge, no more a lack of strategy, but we have only a lack of implementation, and all partners must work to make it better. Climate change is increasing the pressure for action along the Elbe and also in this part. Here you can see a slide. It's also in the internet. All measures which we prepared and realized now and in next years. In blue color, it's I think water management measures. In the orange color is shipping route management measures, and in nature management measures are in green. I said water management, shipping route management, and nature protection are put in equal positions. That's the most important thing of the GKA. And Biosphere Reserve and I, as person, is part of a 4-person commission we create from Federal Republic and federal states. It's the management commission to organize the process of GKA in next years. What is the dimension of GKA in nature conservation? Also tasks to spatially expand, improve, and restore dynamic processes and floodplain typical structures. I said this in the slides before. Under the conditions of a federal waterway. The condition of a federal waterway is a special condition. The river should shape the floodplain more than before. GKA offers waterways, water management, and nature conservation a politically and socially coordinated toolbox for implementing their respective goals. Most important thing, it's a good toolbox for us all and for all partners in equal conditions. Here you can see the actual chart, all measures which are prepared and realized now and last year, this year and next year in Biosphere Reserve. One is the big project, what I said with the Seelman Foundation, but some measures of water retention, some measures of connection of oxbow lakes, flood channels and side arms and so on. That's a very important thing for us. And we use some programs of the Federal Republic, for instance, Blaues Band, and the use is together with partners from the NGOs, also WWF, NABU is an NGO, BUND is an NGO, and some foundations. And most important is the waterway administrations too. Here's some examples of waterway management or to make waterway management more ecological thing better than before. Here's a construction of island structures is for us important for the ecosystem and some species important. And here is a combination from stones. Here you can see, I hope you can see the slide, and deadwood coins. Also in the middle we have deadwood and begin and ending are stones, and this construction is good for some small species, not so for big species and fishes and birds, but for small species, it's an important thing. We try and we open long structures, waterway structures. Such structures are very important for the shipping route, but if you can make it open, you have some aisles and good structures for some species of birds, fish, and so on. It's very important for the ecosystem, and it's possible. Also, it's possible to change these structures to make it better in ecological thing. And we have some success and some good results of breeding birds and so on. An effective reconnection of flood channels, oxbows, and tributaries. From small thing like here and also greater channels and oxbow lakes, it's important for the lateral reconnection of flood plain and the river. Sometimes very small, as a current movement behind riverbank protection. On the right side is the part for shipping route, and on the left side is place to make better ecological things along the riverbanks, or to rebuild riverbanks without stones. Another small thing is the initiation of bank erosion through groin openings. As we open the groin near the banks, and among these things is a breeding ground for sand martins, kingfishers, and bee eaters, and some insects. You can see some breeding points from the species, and it's very important for such species along the Elbe. And waterways are not, or are mostly not much possibilities to breed for such species, and we make it better with such measures. We have some limits of ecological design in context of waterway maintenance. Maintaining the functioning of the Elbe Federal Waterway with the agreed objectives of the GKE sets limits on the ecological transformation of the waterway as whole and of individual structures. The fundamental contradiction between the more static conditions necessary for the waterway within minimum limits, which limit the dynamics of the flowing water, and the ecologically necessary dynamic conditions remains despite the GKE. The scope for action between these two poles, jointly but reliable, defined by the GKA, are far greater than before. They can and must be designed by experienced engineers. I think we need more good engineers, more engineers which are responsible for ecological things and for technical things. And we also need engineers in nature protection organizations and administrations. And better nature engineers in waterway administrations too. According to our shared experience, success factors for maximum exploitation of ecological design options are proactive use of the experience and knowledge potential of all actors. Very important, all actors. Combined with trusting collaboration, only good, courageous engineers open to unconventional ideas can produce good solutions. Courage to use trial and error methods. Not ever important, but not uncomplicated. Possibly with subsequent adjustments. Locally, failure are defined as an important experience that has to be analyzed. Climate reserves must be defined, I said it, and where possible, considered and incorporated. The ecological adaptations of structures should still function decades from now. All available options for erosion control must be exploited in the erosion zone. A resilient, long-standing or existing relationship of trust between the stakeholders is very helpful. I think trust is not only helpful, is very important in my think. I should said some things about monitoring. We have an international monitoring in the International Commission, sediments, water quality, and so on. And in the Biosphere Reserve, and especially after and in restoration projects, we have another monitoring of abiotic factors and habitats. Groundwater and surface water levels, water quality parameters, trophic assessment of floodplain waters. For instance, how nutrient-rich is the water and does this change following restoration? It's very important if you make a restoration of Oxbow Lakes, for instance. Focus on habitats, flora-fauna habitat guideline, mapping of hardwood and softwood floodplains, monitoring of floodplain waters, water courses with floating aquatic vegetation, and wet floodplain meadows. Long-term permanent observation plots in grassland and forest. We have installed. The way forward is an expansion to include the Phyto-C index for Water Framework Directive compliance, drone monitoring in hard-to-access quartz zones, closer linkage between groundwater levels and biotope condition to better understand cause and effect. In species and modern methods, we have some discussions, and one question is which species are present or absent and which locations are highly informative biological indicators. Macrophytes and dragonfly larvae indicate water quality and habit structure. The fire-bellied toad is sensitive to change in the dynamics of small water bodies. Beavers as a keystone species, saprocyclic beetles, and so on. Look into the future. The waders and water birds are directly dependent on water levels and are therefore valuable system indicators. Examples: crane stopover, establishment of wading bird populations. Modern methods in use, we discuss about such things. DNA meta-barcoding enables the identification of entire species, communities from water samples, dragonflies, amphibians, mussels, fish, and so on. Supplement by Malays traps for insect monitoring, also analyzed using meta-barcoding, faster, more comprehensive, more comparable, but I think, in my opinion, also some problems. But it's a discussion between older people like me and younger people like my colleagues, for instance. We aim species groups as a system indicators for floodplain condition and approach transferable to the other European river landscapes. Monitoring in the context here, some slides from species, also fire-bellied toad, Elbe beaver, four-spotted chaser, and the crane, and so on, such species. I will come to the end. Biosphere reserves are model regions for sustainable development and I think a good instrument for river and floodplain restoration. In floodplains, everything depends on water. Successful nature conservation requires effective opportunities to influence the landscape's water balance. GKA secures and defines these on an equal basis with waterways and water management. That's important for us. Within the framework of the GKA, the waterways administration together with nature administrations and water administrations and NGOs provide significant support for the conservation and the development of the floodplain ecosystem in the Elbe River, especially in Germany. This requires contributors on both sides who are open to the continuous development of new solutions and the further improvement of techniques that have been tried already. If all protagonists can maintain and expand the existing relationship of trust in the search for working solutions with mutual understanding and mutual appreciation, the interest of society along the Elbe will be exceptionally well served. Conclusion is, all in all, the GKA offers a reliable framework and a unique historical opportunity. I think it's very important for the Elbe catchment and very important for the Elbe River as a whole in Germany and also for the Czech Republic. We work also in this time and in this GKA together with Czech Republic, and all organizations are members from Czech Republic too. Thank you very much.
Merci, Monsieur Puhlmann, pour cette présentation de ce large cours d'eau également et cette autre démarche de restauration, ces nombreux exemples
and the many examples of restoration,
ailleurs en Europe.
which are perhaps different from what we see elsewhere in Europe. I had the first question about the priorities of the action when you have restoration operations, moving back embankments. How do you have to make choices between preserving biodiversity and sometimes other issues, perhaps of quality, of sediment quality or water quality? And who helps you when you have to make those choices? Is that something you do internally, or do you have teams on site, or do you have scientists to help you?
If you have large areas and long-term projects, it's possible to find solutions for all choices. It's better. You must have an interdisciplinary team, and you must make some discussions to find good solutions. And then you must go to the inhabitants and to land users and landowners, and then you must find a good solution for all. That's the way. And I'm a fan of long-term project. In long-term projects, you have enough time to find good solutions. If you have only 2 or 3 years, it's mostly very complicated, and often you can't find a good solution, and you must realize semi-good solutions. And good is if you have trust relations between the administrations and between the actors. It's my experience. And sometimes it's difficult. I said it in my presentation. In the nature conservation administrations, we have a lack of good technical engineers. in the waterway maintenance administrations in Germany are good colleagues which have studied in nature sciences. But we are not enough have good technical engineers. Sometimes it's complicated in discussions.
Et d'ailleurs, je rebondis là-dessus, en dehors
And to
des
come back to
techniciens
this,
dont vous parlez, des
aside from the
ingénieurs,
technicians or the engineers
dans
you
les
mentioned
Federal Waterways,
in
est-ce
the
que vous
federal
travaillez
waterways,
aussi avec
do you
des
also
chercheurs
work with researchers
d'universités allemandes ou
from
tchèques
German or
qui font
Czech
également des suivis en
universities
parallèle de
who
vous
do
ou qui
perhaps
font les suivis sur
parallel
place?
monitoring or perhaps do the monitoring for you?
We work together with researchers in the structures of GKE or some researchers we have in Germany, some administrations on the federal republics level, also the Federal Agency of Nature Conservation, of Federal Agency of water building, and I'm looking for the English word. Also we have a good research administrations, and what these administrators not know, we take it from the universities and so on. It's very important. It's for us.
Okay. J'aurais une autre question. Comment
I
vous
have
associez
another question.
plusieurs expérimentations.
There are several
Comment vous
experiments.
associez les
How
populations
do you
quand
involve
il y
the
a
local
vous intervenez
people
sur leur terrain?
if you're
J'imagine
working
qu'il y a de la
in their
négociation,
on their land? I
mais
imagine you have
est-ce
to
qu'il y a des
negotiate, but
est-ce que ça fait l'objet de discussions,
are there
qui est
discussions?
autour de la table?
And
Le
if there are,
riverain,
who is around the table?
pêcheur,
The neighboring
qui sont les gens autour de la table
populations,
pour
people
discuter
working
quand
in
vous faites des
fishing,
travaux de
who
restauration?
sits down around the table to
L'industrie,
negotiate,
peut-être?
and
Non,
in
il y a pas,
the
il y a
local
pas.
industry, perhaps, who sits down to negotiate about that?
We two steps. If we initiate as a bioreserve such large project, one of the first step is that I, as director, must go to the most important inhabitants and most important land users. These persons must get the information about such projects from you as a director is better. From you as first, not from other people. It's mostly not so good like when you are the first informator. And along the time of such projects, we installate working groups of most important communes, mayors, and the most important land users or land user organizations. And in these working groups, all things of the next year or next years will discuss. We discussed all things of the project. It's much work. You must spend much time, but without this, it's mostly not is going on.
And
En
another
lien avec le
question,
suivi,
perhaps more about the monitoring.
est-ce que vous avez observé une évolution
Have
des
you
communautés
observed
de
any
macrophytes
changes
suite
in the
au projet de
macrophyte
restauration?
communities after the
Est-ce que
restoration
c'était
projects?
une évolution
And if
positive
so, has this
ou au
been in a
contraire
positive
négative?
sense or in a
Et est-ce que
negative
ce genre de
direction?
résultats, vous les publiez
And
dans des
do you
études
publish
qui sont
any such
accessibles
results in studies
ou
which
dans
are
des
available
publications
or
de
in
recherche ou ailleurs,
publications, in research
pour que ça
publications,
puisse
or
être partagé
elsewhere,
en
so
dehors du
that that
chantier?
can be shared outside your borders?
So the publishing is not enough, but we have some publishings from the federal agencies, which I said, and the monitoring is mostly not so good like the realization. It's for us a task for the next year to be better than before. We have some monitoring targets from the founders of the projects, but it's or others. We have a problem, and now the last 20 years we have some influence of climate change, and this influences are make a failure, or it's very difficult to think what is the impact from climate change and what is the effect from the projects. It's very difficult in floodplain forests. We have some problems with decrease of water levels and so on. And it's the same problem with increasing temperatures in oxbow lakes and in tributaries and in the Elbe River itself. And that's why it's not so similar to think, to find the facts.
J'aurais donc une autre
I have
question
one more question
sur votre démarche
about
globale que vous
your
présentez, donc la
overall
GKE.
approach
Est-ce
to
que ce genre de démarche
GKE.
a été
Does
initié
was
sur
this
l'Elbe, dans votre cas? Est-ce que ça a été copié
initiated
ailleurs
on the Elbe? So
en
this was
Allemagne,
started on the
en
Elbe, but has
Tirol,
this
ou
been
est-ce que pour
copied
l'instant, ça reste
elsewhere in
assez
Germany on other
exceptionnel?
waterways or rivers, or is it something exceptional for the moment?
The GKE is not copied in Germany. It's only along the Elbe River, but some other river basins are interested in Germany, and the Czech colleagues too. But in the Czech Republic, the Elbe is a more important waterway than in Germany. It's so important, like the Rhine in Germany and France, for instance, as waterway, and that's why we in Germany have some more possibilities to make ecological measures. In Czech Republic is more difficult, but the political situation is now also not so similar.
Okay.
Political situation is mostly not similar in Germany too.
Okay. Et est-ce que l'association de la biosphère,
And does
de
the
la réserve de
involvement
biosphère
of the
UNESCO
Biosphere,
avec
UNESCO
votre démarche
Biosphere
de
Reserve
GKE,
in
est-ce
your
que
GKE
elles
process
se
or
sont nourries
initiative,
l'une de l'autre? S'il n'y avait
do
pas eu
they
la réserve de
feed
biosphère,
into
est-ce
each
qu'il y
other?
aurait eu
Without
GKE?
the Biosphere Reserve, would there have been GKE?
The Biosphere Reserve, so we have four things: nature protection, waterway, and water floodplain protection, and so on. And we have four institutions in the commission, and one institution is Biosphere Reserve, and I'm the person which is part of this commission. And then we have sub-commissions too for some people. We have a working group since 1996, which is working against riverbed erosion. I'm a member since 1996, and this commission will work next 20, 40, 60 years too. It's a question for more than one generation. And Biosphere Reserve is a good instrument. It's a long-term structure in administration structure. It's in Germany a very positive thing. We have 18 biosphere reserves. Not all biosphere reserves are so great like the Elbe Biosphere Reserve, but along the rivers, it's a very important structure for us. Also between the federal states. We are not central organized like France. Sometimes it's not. It's very difficult for us to speak from federal state to federal state. That's why such structures are very good for us.
On va prendre deux dernières questions.
Oui,
Can we take two
moi j'en aurais
last
une
questions?
sur,
I see one
plus
here.
particulièrement sur, est-ce que
On,
vous, sur l'Elbe, c'est un cours d'eau channalisé,
so this is
connaissant
a
des problèmes
channelized
d'enfoncement. Est-ce que
way.
les travaux que vous conduisez
Do
sur
the
les
work
anciens
you
dépits,
do on the
finalement, est-ce qu'ils
former
participent
groins,
au
does that
réengraissement
contribute
du vif?
to
Est-ce que
putting more
en gros,
material
les sédiments
into the
partent
banks?
des
Do the
bras morts, plus
sediments
que quelle est leur
move
la
from
dynamique
the
sédimentaire qui arrive
exposed?
dans le
Are
dépit
there
principal?
sedimentary
Est-ce que vous les,
dynamics
est-ce que vous
that
les
feed
suivez ou
the
est-ce que vous
banks, or do you
voyez
monitor
ou...
this, or do you see effects?
Yes, the effects in groin changing or groin adaptation are very local, but if you make some 100 groins better, the effects are not only local, but, but the effects are important for populations of some bird species, especially. Sand martins, for instance, and kingfishers, the population is increasing in such structures. For instance, is this okay? Or?
Oui, très bien.
Et petite dernière question,
And
vous en
one
avez
last
déjà en partie parlé à
question. You have
propos
already
du
spoken
public, du grand
to
public,
some extent about the
que
general
vous sollicitez, que
public,
vous
the
informez.
population who you do inform.
Vous le faites via
Do you
aussi des
do
phénomènes,
this
une organisation d'une concertation publique
through
qui
other
sont assez
public
nombreuses, à laquelle vous
consultation
participez, vous me disiez en
bodies
tant
in
que
which you
directeur,
take
c'est
place
important
as
que vous ayez les
director?
informations
It's important that
directement,
they
donc
get the
vous
information
participez comme
directly
ça à de
from
la
you. So does that mean you take part in
très locale et assez
consultations
fréquente. Quand vous avez des
frequently
projets de
at
restauration
local
pour les
level
présenter,
when there are
discuter,
restoration
les
projects to
modifier?
present them, to talk about them, or perhaps to modify them?
I didn't understand the question in white. Sorry.
Non, je revenais sur
So I was talking
la façon
about
dont vous
the way
concertez, vous
in which
communiquez
you
avec
consult
le public.
and communicate
Est-ce que vous
with
le
the
faisiez sous
general
forme de
public.
concertation publique
Do you do this through
globale,
public
où vous veniez en tant que
consultations where
directeur
you
et
come
vous
as
expliquiez, vous
director
aviez vos
to
équipes? Ça
explain
se faisait de cette
with your
manière-là ou c'était des
teams,
fois
or
des
are there
petits groupes plus
sometimes
petits?
in smaller groups that you communicate with people?
Most important, if you will make a project, you must communicate on a local level. It's very important. You must take time to speak with everybody. It's the best. It's sometimes difficult if the areas are big or large and the population is big, but it's the best way. It's a good invest of time, I think. And on next level, on the community and administration level, counties and federal state, it's also important. You must go to the parliaments of the counties and of the federal states. But the most important is you must go to the people which lives where you will make a project, and land users too.
Très bien, merci beaucoup pour votre participation.
Thank you very much for taking part and for your presentation. We've reached the end of this webinar. We're running a tiny bit late as there was quite a lot of very dense discussion. I would like to thank our two speakers for taking the time to share their experience on these two water courses, all our different participants for taking part. It shows how interested you are. So we've seen two presentations on large-scale restoration work in line with things we've studied with I.S.Rivers. We've seen the link with sediments. Both water courses are concerned by similar phenomena, and we have the examples of restoration strategies on a large scale and even multi-country scale, which is important, with a lot of research, varied research work, which can provide lots of ideas for participants. So, as I said in the introduction, The two presentations have been recorded. There will be replays in English and French, which are available. You'll have to give us a few weeks for that to get organized. That will be on the Graie web page, but you will be informed about that. And without getting ahead of myself, I think we should be able also to share the contact details of our two speakers with the participants if ever anybody would like to ask more precise questions about the themes. Okay, so thank you once again to all of you and enjoy the rest of your afternoon. And I hope to see you again soon to talk about rivers.